Hello everyone, my name is Woojin Park. I'm a PhD in industrial engineering, specializing in the field of human factors and ergonomics. The lecture materials I am presenting to you for the next two classes are concerning human factors and ergonomics, which is closely related to user experience. I'll be talking about some basics of human factors and ergonomics, such as major concepts and definitions, and the topic of human variability and user accommodation. Now, let's begin. Human factors and ergonomics is concerned with the design of systems for human use. In human factors and ergonomics, great design is accomplished by considering human characteristics, limitations, and preferences during the design. This also means that failing to consider the human element during the design can lead to poorly designed systems. To appreciate the importance of human factors and ergonomics, let's examine some examples of poorly designed systems. Here is a road sign. Can you interpret the meaning of the road sign? Which way to go? Is the meaning clear to you? The road sign is not clear in its meaning, as it could be interpreted as either do not go to the left or do not go to the right. The confusion stems from the fact that this do not symbol here could be associated with the leftward direction, or it could be associated with the arrow pointing to the right. A human factors engineer who is knowledgeable in human information processing would create a much better design than this one. Also, they can help identify and correct design flaws like this one. Now, let's examine the directional sign for wayfinding shown on the slide. Suppose that your task is to determine which way to go to get to Suite 521. Can you do the task easily? If not, why not? It turns out that the sign is very difficult to use as it has elements that are not consistent with human expectations. People associate each direction in the space with the direction of change in a numerical value. For example, the upward direction is associated with the increase in a value, whereas the downward direction, the decrease. Similarly, the rightward direction, the increase, whereas the leftward direction, the decrease. These expectations or rules are not respected in the sign. Lower values are above larger values, and we can also see that a larger value is on the left side of a smaller value in the left-right direction. Again, human factors and ergonomics can help eliminate this kind of design flaw. Another example of a poorly designed signage for wayfinding. The two symbols depicted on the slide, represent distinct locations within a parking structure. But can you easily distinguish one from the other? If not, what is the problem? Think about it. The problem here is that the two symbols representing two different locations share too many similarities. While they are identical in terms of the text label, color code, and positional code, the only difference between them is the direction of the human figure. Even the difference would not be easily detected at a glance. You have to very carefully examine the human figures. This signage system is expected to cause much confusion and waste of time to those who park their vehicles in the parking structure, and would negatively impact the user experience of the people using the venue. Now, let's think about this knob found in a bathroom sink. It is shiny and looks good, but how is it in terms of ease of use? Can a user easily use it? The trouble is that the surface of this knob is too smooth and slippery. With the soap in the wet hand, the user would not be able to get a firm grip on it, making it difficult to turn. An aesthetically pleasing design alone does not necessarily guarantee excellent user experience. Both aesthetics and ease of use, that is, usability, must be considered. The next example of poor design involves two lever controls situated close to each other on the floor of a vehicle's interior. Unfortunately, they are positioned in an area with inadequate illumination, making it difficult to visually distinguish them. Consequently, the driver often makes mistakes, such as inadvertently opening the bonnet instead of the intended action of opening the fuel cap. The design flaw here is glaringly apparent. When designing any product or system that requires human physical interaction, it is crucial to account for body dimensions. The consideration of human body dimensions in the design of products and systems is called engineering anthropometry. Now, let us talk about the design of work tasks and their impacts on human health. First, consider the working postures shown on the slide. One is from construction, the other manufacturing. Can you see problems with these working postures? The posture on the left involves extreme arm elevation. The arms are above the shoulder level. Such an upper extremity posture is known to impose large stresses on the shoulder area and can give rise to musculoskeletal disorders. The posture on the right poses problems as it requires torso bending and twisting. Furthermore, if the shoe floor interface becomes slippery, there is a risk of losing balance. These unfavorable working postures are a consequence of neglecting the human element in the design of work tasks. It is essential for work task design to prioritize the well-being of workers, as these efforts not only enhance their health, but also contribute to increased productivity. Instances of poor work design are prevalent across various sectors, including agriculture, service, healthcare, and domestic work. The poor working postures and excessive mechanical loadings on the human body could be alleviated through the use of well-designed equipment and work methods. That is also within the scope of human factors and ergonomics, and is important for improving the worker experience. The design of everyday work tools, such as laptop computers and mobile devices, seems to require some improvement. As can be seen in the picture, the use of poorly designed work tools and work methods result in neck bending and twisting. And in turn can cause musculoskeletal problems in the body area. The bad design example shown on this slide is from a control room of a nuclear power plant. What are the problems that you can see? First of all, there are too many displays and controls. Can a human operator deal with such information overload and correctly understand the system state and quickly respond when necessary? Also, some controls are difficult to reach, as shown on the picture on the left, and some displays are impossible to perceive unless some extra prop is used, as shown on the right. These also make it difficult for the operator to monitor and control the system effectively. Improper design can often result in disasters. One well-known example is the nuclear plant accident at 3 Mile Island. Let me read the passages of a newspaper article. In 1979, there was a core meltdown at 3 Mile Island, the most dangerous type of nuclear plant accident. As coolant poured away from the reactor, those on duty could not understand what was happening due to confusing information on their instruments. And so they inadvertently took action that made things worse. Bothell and Chernobyl too have primarily been attributed to operator error. What do you think about this term, human error? An important aspect to remember is that while we use the term operator error, it is crucial to understand that operators themselves are not at fault. The true underlying cause of operator error lies in inadequately designed human interfaces, especially poorly designed displays and controls. It is unfair to blame individuals for their inability to carry out a task when the task was initially designed to be unachievable. Okay, great. We have now explored several instances of poor design to emphasize the significance of incorporating the human element in system design. Prior to presenting a formal definition of human factors and ergonomics, I would like to introduce a well-known quote from George Bernard Shaw, as displayed on the slide. Let me read the slide. The reasonable man adapts himself to the world. The unreasonable one persists in trying to adapt the world to himself. Therefore, all progress depends on the unreasonable men or women. As engineers and designers, our collective aim is to drive progress and enhance human conditions. To achieve this, we must embody the spirit of the unreasonable person, striving to mold the world to meet human needs. This pursuit aligns precisely with the mission of human factors and ergonomics. This slide shows one definition of human factors engineering, also known as ergonomics. Let me read the definition. Human factors engineering is the systematic application of relevant information about human capabilities, limitations, characteristics, behavior, and motivation to the design of things and procedures people use, and the environment in which they use them. This definition is from the well-known textbook by Sanders and McCormick. Here's another definition of human factors / ergonomics, which is similar to the previous one. Human factors discovers and applies information about human behavior, abilities, limitations, and other characteristics to the design of tools, machines, systems, tasks, jobs, and environments for productive, safe, comfortable, and effective human use. The definitions, this one and the previous one, reveal that human factors encompasses two primary aspects. The first aspect involves the gathering of information and knowledge about humans, including their behavior, abilities, limitations, and more. In this context, human factors is closely intertwined with other disciplines, such as psychology, social sciences, physiology, and biomechanics. The second aspect revolves around design. The acquired information and knowledge about humans are applied to optimize the design of diverse systems, ranging from tools, machines, and systems to tasks, jobs, and environments. The ultimate objective of design is to enhance human well-being and productivity.